Okay, so here are the examples for the quiz. Notice when I give you the examples, I give them to you backwards. Here's the hardest ones, and the easiest ones are at the end. So let's go ahead and start at the end. So we need to find the basic indefinite integrals. So this one is simple power rule. We're just going to add 1 to the exponent, so I get x to the 4th, and then multiply by the reciprocal of that exponent. And because it's an indefinite integral, I have to add the plus c. Bam. That's that one. Okay, the next one, sine of x. All right, so if you are in need of it, get your notes. I should grab a formula packet, because all of these integrals are in the formula packet. You should be able to use the formula packet. Why do I keep making these videos when I'm not ready? Pick up stuff. Okay. So going to the last page of the formula packet, if I look on here, I can find the ones that I need. So for this next question, it says, where was I? Sine of x. Sine of x, the antiderivative is negative cosine of x. Okay, so this is, again, just practice using the formula packet, basically. So the antiderivative of sine of x is negative cosine of x. And since it's an indefinite integral, plus c. Bam, that's it. Okay, the next one, e to the x. Again, there it is. What's the antiderivative of e to the x? E to the x. Okay, so if you ever forget, they are on your formula packet. So that's e to the x plus c. That's it. And the last one, is that on the formula packet? Oh my gosh, it is. It's right there. 1 over x. That equals natural log of x. Okay, so this is equal to natural log of x plus c. Bam. Okay, so level 1 basic is, can you look up the answer on the formula packet? All right, the next one, how about can you do a simple, I should have said simple definite integral, because here we are actually going to evaluate it from -1 to 1. Okay, so notice it's in 2 pieces. So I'm going to go ahead and integrate each piece. So this one, I'm going to put my 3 to the side. My x is going to add 1 to that, so I get x to the 5th. So I need to multiply it by 1 over 5. So I have 3/5 times x to the 5th. Hey, the other one, I have my x. I'm going to add 1 to the exponent, so x to the 4th. And I need to times by the reciprocal, 1/4. And I keep the 4 that was there. Now I can simplify that. That just gives me x to the 4th. Now I need to evaluate that on the interval, -1 to 1. So when we evaluate it, we put in for x, we put in our big number first. So I'm going to have 3/5 times 1 to the 5th plus 1 to the 4th. That's going to be the evaluation with the upper boundary. Then I'm going to minus the evaluation with the lower boundary. So I'm going to, notice I put my parentheses, super important. Don't forget to put the parentheses after the minus, because you have to figure out this answer and then subtract it from this answer. Super important. All right, back to work. 3/5 times -1 to the 5th plus -1 to the 4th. All right, now let's simplify this. Thank goodness for the number 1. 1 to the 5th is 1. 1 times 3/5 is 3/5. And 1 to the 4th is 1. I'm going to go ahead and write that as 5/5. 1 to the 4th is 1. Okay, I'm going to change 1 to 5/5 so that I have a common denominator. So I get 8/5. Okay, so that's the first part of the evaluation. Now over here, -1 to the 5th is -1. So inside here, I'm going to have -3/5. -1 to the 4th is +1, so that's going to be +1. Again, I'm going to write it as 5/5, so I have a common denominator. And this is my minus sign, bring it on down. So if I simplify that, -3 plus 5 is 2, so 2/5. And then I have 8/5 minus 2/5, and that gives me 6/5. So there is my simple definite integral. Okay, had a lot of steps, but none of them were too horribly tricky. All right, next one is I am going to, let's see, what is the instructions? I can use substitution to find an indefinite integral. Aha! So it's telling me this is about substitution. Let's go ahead and do A, B in that order and see what's going on. Okay, first of all, when I'm integrating, I don't like the square root sign because do I have a rule with a square root sign? I certainly do not. Is it late at night and I'm getting punchy? Yeah. Can you tell? Perhaps. All right, so I'm going to rewrite this. Yeah, no, let's just leave that there. 4, and then parentheses, 4x minus 1 to the 1/2. Okay, a square root is a 1/2. And then I have my dx. I've already given you a hint. We're going to be using substitution. So that means I'm going to make my u. So my u is the x with the highest exponent. Well, that's my only x. So my u is going to be equal to 4x minus 1. So my du dx is going to be equal to 4. So this is my du dx. This is my u. So now I can rewrite my integral in terms of u. So the 4 is du dx. And here I have u to the 1/2 dx. The dx's cancel out. And I'm going to rewrite the order u to the 1/2 du. So now I just need to take the antiderivative of u to the 1/2. So to take my antiderivative, I add 1 to the exponent. So 1 is the same as 2 over 2. So that gives me u to the 3/2. And I need to multiply by the reciprocal of that. So 2/3 times u to the 3/2. And now I'm going to substitute back in my u. So 2/3. U is 4x minus 1 raised to the 3/2. And then, since it's an indefinite integral, plus c. There it is. All right, same thing here. Again, I don't like having a square root sign, so I'm going to rewrite this. I always write too big. So I'm going to put a little line. Okay, so I'm going to rewrite this. X squared times times x squared plus 5, and that's to the 1/2 dx. And let's see, my u is going to be x cubed plus 5. So my du dx is equal to 3x squared. Okay, so notice I have the x squared, but I'm missing the 3. So I'm going to rewrite my integral with a 3x squared. But if I put a 3 there, to counteract it, I got to put a 1/3 here, because 1/3 times 3 is 1. So now I haven't changed anything. And then keep going, x cubed plus 5 to the 1/2 dx. Now, here's my u, and here's my du. So I can rewrite the whole thing as 1/3 du dx times u to the 1/2 dx. The dx's cancel out, and I have 1/3. I'm going to write the u to the 1/2 first, du. And now I can take the, do the integral of that. Well, I already did that up here, so I'm just going to steal it from up there. And I'm going to, sorry about this, I'm going to go back over to here. So I still have my 1/3. And then u to the 1/2 is just this, right? We add 1 to the 1/2, so we get u to the 3/2 times the reciprocal of that times 2/3. But now I need to multiply that with the 1/3. So I get 1 times 2 is 2, 3 times 3 is 9, u to the 3/2 plus c. There it is. Okay, there's one more of these substitution ones. So on the back. Okay, so looking at this, again, I look for my higher exponent. That's right here. So it looks like my u is going to be 4x cubed plus 6. So my du dx is equal to 12x squared. And the 6, well, that just goes away. The derivative of 6 is just 0. So now I'm going to say, okay, this is my u, but this is not 12x squared, so I need a 12. So if I put a 12 there, I have to put 1 over 12 out here to counteract the 12, because I'm just multiplying by 1. So now if I rewrite this, I get 1/12. 12x squared is my du dx. Here's my u. Oh, it's not raised to anything. Oh, you know what? I could have actually distributed this and done it another way, but whatever. I'm already here, so might as well finish up. All right, so dx's cancel out, so I'm left with 1/12 times the integral of u du. So now I'll take the antiderivative, so I have u. This has an invisible exponent of 1, so I'm going to add 1 to that, and I get u squared times that by the reciprocal of 2, so 1/2. And don't forget my 1/12 over here. So that gives me 1/12 times 2 is 24, and I'll go ahead and substitute back in my u for x cubed plus 6 and plus, oh, don't forget my squared, plus c. There it is. So I was actually realizing that since the parentheses don't have an exponent on it, I actually could have done this by just distributing this, and I could have done the integral of 4x to the 5th plus 6x squared, and I could have integrated that, both of those separately. The answer would have looked a little bit different than this. So should I go ahead and do that? Why not? Let's go ahead and show what that answer would be. So if I did it this way, I would do each part one at a time. So x to the 5th would become x to the 6th times 1/6 times 4, plus this one, x squared would become x to the 3rd times 1/3 times 6. So if I simplify that, I get 4/6 x to the 6th plus 6 divided by 3 is 2, x to the 3rd. This is 2/3 x to the 6th plus 2x to the 3rd. Now, is that the same as what I have here? Well, here I would have to multiply it out. Now I'm like wondering, why did I bother? Okay, 4x cubed plus 6 times 4x cubed plus 6. 4 times 4 is 16, x to the 6th. 4 times 6 is 24, x cubed plus 24, x cubed plus 36. And then, wait a minute, what happened here? Why doesn't this have a 36? That's interesting. So I think it's going to end up with a slightly different answer. Okay, combine my like terms. Oh, this is, I still have my 124. So combine my like terms. 16x to the 6th plus 48x to the 3rd plus 36. So if I distribute this, I get 16 over 24 x to the 6th plus 48 over 24 x to the 3rd plus 36 over 24. This reduces to 8 goes into this, 2/3 x to the 6th plus 2 x to the 3rd plus 36 over 24. And then it would be a plus c. So notice, where was I? Here it is. So here it is. If I had distributed first, I would have gotten this answer. If I don't distribute, if I use substitution, I get this. So, and this is plus c. So notice the constant here, well, this would be a different constant because I already have this part here. So because I would be adding some other number here, I wonder if it really matters. So that's interesting. Two different answers. Huh. Since I asked you to do it with substitution, I would actually have been looking for this answer. This is the answer I would have been looking for using the U substitution. But I'm just kind of wondering, what? Huh. Interesting. All right, so there's that. All right, now for the hard ones. I'm going to have to come back and look at that. Why are those two answers different? So I'll make that a different video. Okay. So, next one. Ooh, look at this. I have an e to an exponent. That's got to be my u, right? Whenever we have an exponential, that's got to be my u. So, I'm going to say that u is equal to sine of x. So, therefore, du dx is equal to the derivative of sine is cosine. So, I see I have a cosine. There it is. So, that's my du dx. So I'm going to rewrite this as cosine x is my du dx. This is kind of hard to tell, but this is the lower limit and this is the upper limit, the 0. to the pi over 2. I had a hard time with that font size there. Sorry about that. And then I have e to the u dx. The dx's cancel out. And I'm left with, from 0 to pi over 2 of e, what am I doing? E to the u du. The antiderivative of e to the u is just e to the u. And I'm going to evaluate that from 0 to pi over 2. I'm going to substitute back in for my u. So I get e to the sine x from 0 to pi over 2. So from our unit circle, I'm going to need that. This is 0 is 0, is 1, 0. And pi over 2, this is pi over 2, is 0, 1. So when we get to evaluating this, I'm going to need this. All right, so I'm going to evaluate first with pi over 2. So I'm going to get e to the sine of pi over 2. And I'm going to subtract from that e to the sine of 0. So sine of pi over 2 is 1. So this is going to be e to the 1. That's the first part. Sine of 0 would be 0. So I'm going to get e to the 0. So e to the first is just e, and e to the 0 is 1. So that is my answer. And this quiz is without a calculator, so I wouldn't expect you to go any farther than that. All right, the next problem. The next problem here, we want to evaluate from z to that. Okay, so again, I've got an exponential, so this is going to be my u. So my u is equal to x cubed plus 8. So my du dx is going to be equal to 3x squared. So if I, let's see, what have I got? So I don't quite have the du dx. I'm missing a 3. So I'm going to have to put in a 3. If I put in a 3 there, I have to put in a 1/3 out here. So now I can rewrite. This is separate. I'm going to rewrite this now. 1/3 times the integral from -2 to 0. 3x squared, this part right here, is my du dx. E to the, here's my u, dx. Cancel out my dx's. I'm left with, oh, it's just like the other one. E to the u, the derivative of that is just e to the u. So my antiderivative is going to be, I still have my 1/3, and I have my e to the u, and I'm going to evaluate it from -2 to 0. So I'm going to start with the 0. So my first one is going to be 1/3 times e to the 0 minus 1/3 times e to the -2. And if I simplify that, e to the 0 is just 1. So 1 times 1/3 is 1/3. And over here, e to the -2 is e squared in the denominator, so this would be 1 over 3e squared. To get these to have a common denominator, let's get this out of the way. I would need to multiply the first fraction by e squared over e squared. So I end up with e squared minus 1, e squared minus 1, all divided by 3e squared. That is the most simple answer, writing it as one fraction. Don't like to leave a fraction written, an answer written as two fractions with two uncommon denominators. Might as well get a common denominator and add them together. So that would be the best answer. If you had left it as 1/3 minus 1 over 3e squared, I'd probably be fine with that. Okay, so that is all the examples for the quiz, and I need to go back and have a look at what happened here. So I'm going to double check on that. But the way that I do want you to solve these is with substitution. So I'll make sure that I pick problems that don't give me these strange, random, different answers. And it wasn't like that different. It was just a matter of when I did it by multiplying it out first, I ended up with an extra an extra constant, which I don't think is a big deal, but I need to look into that and get back to you on that. Okay, that's it. Bye.